Hey everyone, and welcome back. In our last explainer, we got to know the three states of matter, right? Solid, liquid, and gas. Well, today, we're diving into the really cool follow-up question.
So, can matter actually change its state? Can a solid turn into a liquid? Can that liquid then become a gas? Let's get into it and find out.
The answer is a huge yes. And honestly, the best example is something we see every single day: water. Think about it. You've got solid ice, you've got the liquid water we drink, and you've got that gassy vapor or steam coming from a kettle. It's all the same stuff, just wearing different outfits. Okay, let's start our first investigation. We're going to solve what I like to call the mystery of melting. What really happens when you heat up a block of ice? So picture this experiment with me. We've got a beaker full of ice, and we stick a thermometer in it. It reads 0 degrees Celsius, exactly. Now we start gently heating it from below. We're watching the ice or watching the thermometer. What do you think is going to happen to that temperature? But here's where it gets really weird. The heat is on, the ice is melting, but the thermometer is totally stuck at 0 degrees. It just will not move until every last bit of ice has turned to water. So, where is all that heat energy going? And here is the big secret. That energy isn't making the particles hotter, not yet anyway. It's actually being used for a very important job. It's busy breaking apart the strong bonds that hold all those water particles together in that rigid, solid ice crystal. Scientists have a really cool name for this: latent heat of fusion. Latent literally means hidden. It's hidden heat because it's being absorbed without making the temperature go up. This also means that water at 0 degrees has more energy than ice at the exact same temperature. Crazy, right? It soaked up all that hidden power.
All right, now that all the ice is melted, let's keep going. Let's turn up the heat and see what happens next. This part is called from boiling to burns, and you'll see why in a sec.
So with the ice all gone, now that heat energy can finally get back to work making the water particles move faster and faster. The temperature on our thermometer starts climbing, 10 degrees, 50, 90, all the way up until it hits 100 degrees Celsius. And that, my friends, is the boiling point of water. Now pay attention to this because it's a super important safety tip that perfectly explains our next point. You would think that boiling water and steam at the same temperature would be, well, the same, right? Nope. Steam can cause way, way worse burns. But why? You guessed it, it's that hidden heat all over again. See, at 100 degrees, the water particles have to absorb a ton of extra energy just to break free from the liquid and escape as steam. We call this the latent heat of vaporization. So that steam is packed with all this extra hidden energy, which is exactly what makes it so much more dangerous. Okay, things are about to get even weirder. So we've gone from solid to liquid to gas. But what if a solid could just skip being a liquid altogether? What if it could just poof and go straight to being a gas? Well, we can actually see this happen. Imagine we heat up something like camphor. We put it in a dish and cover it with a funnel. As it heats up, something incredible happens. The solid camphor doesn't melt into a puddle. It just seems to vanish into a gas. And then you can actually see it turn back into a solid on the cooler parts of the funnel. This amazing direct jump from a solid to a gas is called sublimation. And when it goes the other way, from a gas straight back to a solid, that's called deposition. It's like finding a secret portal between states of matter. So far, we've only been playing with temperature, but it's not the only tool we have. Let's see what happens when we put things under pressure. Check out this cylinder full of gas. If you push down on that piston, you're applying pressure, right? You're literally squishing those gas particles closer and closer together. If you apply enough pressure and maybe cool it down a bit, you can actually force a gas to become a liquid. And the perfect, super cool example of this is dry ice. Dry ice isn't frozen water. It's actually solid carbon dioxide, or CO2. It's kept solid under super high pressure. The moment you release that pressure, it doesn't melt. No puddles. It sublimates. It goes straight from a solid to a gas, creating that awesome, spooky fog you see in movies. And that's why they call it dry ice, because it never gets wet. Whew, we've learned a ton of new words today. Fusion, vaporization, sublimation. So let's pull it all together and look at a complete map of how all these changes connect. This little triangle shows everything. Going from a solid to a liquid, That's melting, also called fusion. Liquid back to solid, that's freezing, or solidification. Liquid to gas is vaporization, and gas back to liquid is condensation. And, of course, our two shortcuts: sublimation, from solid to gas, and deposition, from gas straight back to solid. So what's the one big thing you need to remember from all this? The state of matter is not set in stone. It all comes down to two main things: temperature and pressure. If you can control those, you can control the state of pretty much any substance. And that's a wrap on how matter changes state. In our next explainer, we're going to dive into a really cool process called evaporation. So I'll leave you with this question to think about. What if a liquid, like a puddle drying up on a warm day, could turn into a gas without ever having to boil? We'll find out next time.